Cloud Identity is a Google Cloud solution that helps organizations control and manage access to resources in order to maintain the security and integrity of both data and systems. An Identity Access Management Policy, or IAM policy, is made of three parts: who, can do what, and on which resource. The who part of an IAM policy can be a Google account, a Google group, a service account, or a Google Workspace or Cloud Identity domain. The can do what part is identified by IAM role. There are three kinds of roles in Cloud IAM: primitive, predefined, and custom. Let's talk about each in turn. Primitive roles are owner, editor, and viewer, and are broad. An account administrator, for instance, would apply primitive roles to a Google Cloud project, thereby affecting access to all resources in that project. If you're a viewer of a given resource, you can examine it but not change its state. If you're an editor, you can do everything a viewer can do, plus change its state. And if you're an owner, you can do everything an editor can do, plus manage roles and permissions on the resource. Be mindful, though, if several people are working together on a project that contains sensitive data, assigning primitive roles is not the most effective approach to security. Fortunately, Cloud IAM provides more granular roles. Now, if you're not sure what permissions to grant specific users, Google Cloud Services offer their own set of predefined roles that align with typical responsibilities of people using those services. Each role is a collection of permissions. The cloud service defines where those roles can be applied. For example, you might be familiar with Compute Engine, which offers virtual machines as a service. Compute Engine also provides a set of predefined roles that can be applied to Compute Engine resources in a given project, a given folder, or an entire organization. As another example, consider Cloud Bigtable, which is a managed database service. Cloud Bigtable offers roles that can be applied across an entire organization, to a particular project, or even to individual Bigtable database instances. What if you need something even more granular? That's what custom roles permit. Google Cloud recommends using a least privilege model in which each person in your organization is given the minimal amount of privilege needed to do their job. So, for example, maybe you want to define a role to allow some users to stop and start Compute Engine virtual machines, but not to reconfigure them. Custom roles allow you to do that. Organizations that use custom roles need to manage the permissions that make them up. Some companies decide they'd rather stick with the predefined roles because they don't want to spend time managing custom ones. If you're thinking that assigning and managing all these permissions is going to be time-consuming and difficult, don't worry. An organization can easily map job functions within the organization to specific groups. For example, a sales group for the sales team, or a marketing group for the marketing team. Each group can then be given specific roles for specific resources. This means that users get access only to what they need to do their job, and admins can grant default permissions to entire groups of users. Using permissions helps keep your organization secure when you're using Google Cloud products and services. Now that I've covered Cloud Identity Access Management, let's examine the resource hierarchy.